Welcome back to Patch Math. So far, we've been factoring polynomials using the GCF method, factoring by grouping when we have an even number of terms. And then in the last video, we just discovered how to factor by grouping with an odd number of terms. The AC method is what we use for quadratics, but it will apply to things that are quadratic-like in nature. Looking here, number 8 is another problem that we need to use the AC method on. We have 3 terms, and we need to get this to be 4 terms so we can apply factoring by grouping. We're going to find A times C, the same thing that we started with in the last video. A times C is 2 times 21 here, and 2 times 21 is 42. So now we're looking at those factors of AC that add up to B. And apologies for my messy handwriting there. All right, that's a little more legible on my part. And we're still going to look at the factors of AC that add up to B, and our B is 17. That's positive 17. Remember, each term takes the sign to the left of it. So the factors of AC that could potentially add up to 17. We know we have the 1 and 42. In this case, it's obvious it's not going to become 17, so I'm going to skip those. We got 2 and 21. There's still no way to get those to be 17. So then we got 3 and 3 times 14 will equal 42, and 3 plus 14 will equal 17. Ding, ding, ding. We have a winner. So in this case, we can put 3b plus 14b or 14b plus 3b. Either work because each of those terms has the same exponent. And order is determined based on exponent. So same exponent, they can go in either order. This 3 is positive. We do want to bring the other parts on down. That is our 2b squared and our 20. We just used the AC method to turn that trinomial into a 4-term polynomial. This is scratch work or side work. I'm going to go ahead and shrink that on down. Moving on, now that we have 4 terms, we can finish factoring this quadratic by using factoring by grouping. You split it right down the middle. After it is split right down the middle, like we did with all other prior factoring by grouping, we're going to factor the left group, then we're going to factor the right group. All right. So I tend to tell my students, let's not get overwhelmed. Let's go ahead and cover up our right group so we can focus on our left group. Looking here, using the GCF method, we'll see that 2 and 3 do not share a common factor other than 1, so we don't need to write that down. But b squared and b both share a common factor of b. In other words, b can evenly be divided out of both of those terms, leaving behind 2b plus 3. All right, now that we've got that, we can cover up that left-hand side and look at the right-hand side. We see that our numbers 14 and 21, well, a 7 will fit into both of those. And that will give us our goal. If we factor out a positive 7, we will find that 14 divided by 7 is 2. The b is untouched because there is not a b in the second term here in that 21. We cannot pull out a common factor of b. So we only have a constant pulled out, and 21 divided by 7 is 3. Ding, ding, ding. We've done exactly what we were supposed to do. If at this point you don't have our goal for factoring by grouping, which is the common binomial, then that means you either did something wrong or this one is not factorable with this method. In this case, we do have that common goal of 2b plus 3, that common binomial that we can factor out, that we can divide out. And so moving that 2b plus 3 out front, if we multiply that 2b plus 3 times what's remaining, the b plus 7, we will be able to get the original quadratic right back out. And if you ever want to check to see if you factored correctly, you can use what's called the FOIL method in order to multiply these binomials and see that they will go back to the original trinomial. All right, and there you have it, a good overview of how to factor polynomials in the many forms that you may see them in your Algebra 1 class. And your math knowledge has just been patched. Thank you so much for your time.